Watch this video in Lesson Reach. Pause and ask questions, take a quiz, or get help with assignments. Link below.
You know, when you jot down a phone number or a tip on a receipt, you probably don't feel like you're executing this ancient, highly compressed algorithmic code. You just, scribble a 7 or a 3. But what if the numbers you write down every single day aren't actually numbers at all?
Yeah, that is such a mind-bending way to look at something we do almost unconsciously. And to help you, our listener, unpack this today, we're diving into Section 4.1 of Chapter 4 from Contemporary Mathematics.
Right, exactly. And for this deep dive, I'm going to play the curious student. So just talk to me like I'm sitting right there in Math 101.
I love that. I will gladly take on the lecture role today, so let's just get right into it. To understand how we compute, Section 4.1 makes this really crucial distinction right off the bat. You basically have to separate the idea of a quantity from the symbol you draw.
Oh, interesting. So they're not the same thing.
Not at all. In mathematics, a number is, well, it's an abstract idea representing an amount. But a numeral, that's just the physical ink on the page used to represent it.
Okay, let's unpack this because the textbook uses that John Smith analogy, right? Like the actual person standing there is the number. But his titles, father, brother, uncle, those are the numerals.
Yeah, exactly. The underlying reality never changes, just our shorthand for it. And for thousands of years, that shorthand was incredibly tedious.
Oh, like carving tally marks into a bone or something?
Right, or basic Roman numerals, 1 mark per item. It's essentially just repeating symbols over and over, which, as you can imagine, gets pretty out of hand.
Yeah, you can't exactly run a global trade empire by carving 10,000 individual tally marks.
Exactly. And that economic pressure, the need to calculate quickly across these vast trade roads, that is why our modern Hindu-Arabic numerals took over. They actually started in India.
Oh, really? I always thought they were Arabic.
Well, they passed through there, but they started in India, where a mathematician named Aryabhata of Kusumapura was using place value notation way back in the 5th century. From there, they moved through Persia and the Middle East, and they offered such incredible efficiency that they completely replaced Roman numerals in Europe.
Wow. Okay, but here's where it gets really interesting, though. The textbook mentions that Brahmagupta introduced the actual symbol for 0 a whole century after place value was already working. And as your student, I have to push back here. Why is a symbol for literal nothing such a massive technological leap? Like, couldn't merchants just leave a blank space on their ledgers?
Well, what's fascinating here is that nothing is actually the anchor of the whole system. 0 isn't just some empty void. It acts as a mandatory placeholder for skipped powers of 10.
A mandatory placeholder.
Right. Think about it. If you leave a vague blank space on a parchment ledger, the numeral 4098 and 498 look virtually identical.
Oh, wow. Yeah, in the high-stakes trade, that ambiguity would be completely disastrous.
Exactly. So the physical symbol of 0 forces every other digit into its correct absolute position. It physically shoves the 4 into the thousands place.
Right. But what mathematical magic are those places actually representing, though?
They represent a base 10 positional system. Like most of us just see a numeral like 738 and say 738. But Section 4.1 shows us how to decode this using expanded form.
Oh, okay. Decoding. I like that.
Yeah, mathematically, 738 is a hidden exponential expression. So it's 7 times 10 to the second power, plus 3 times 10 to the first power, plus 8 times 10 to the 0 power.
So wait, what does this all mean? As you read left to right, you are actually reading a string of exponents that scale down by 1.
Precisely. You aren't just writing digits next to each other. You're writing out a solved equation.
That is wild. The everyday act of writing 738 isn't just basic writing. It's a shorthand for an ancient, complex exponential equation developed over centuries.
Yeah, and it proves that our entire system of counting, of building bridges and launching rockets relies entirely on powers of 10.
But why 10, though? Like, if human counting evolved around powers of 10, it's just biology, right? Because we have 10 fingers.
Yeah, it's basically an anatomical coincidence that became the foundational code for our civilization. We count by tens because that's the hardware we were born with.
Which leaves you with a pretty wild thought to chew on. If our entire mathematical and scientific reality was built around powers of 10 just because we have 10 fingers, how radically different would our math, our science, and our understanding of the universe be if humans had evolved with just 8 fingers?
Right. It definitely changes how you look at a grocery receipt.
It really does. Something for you to think about the next time you jot down a quick 7 or a 3. Those little symbols are doing a lot more heavy lifting than you think.